Nani Godiana, hebu cheki email chat.
اي حاجه والشركه تشيل كل حاجه تمت خلال الفتره تاسيسها دي. ايوه قال لي يا خالد يا محمد انتوا صرفنا حاجه؟ قال لي ما صرفناش حاجه.
All right. Thank you all for joining. I see more are joining us. And right now it's 12 p.m. East African time and 10 a.m. CET. Thank you so much for joining us in time. I know more will be joining as we go, but we need to start because we have only 2 hours for this webinar. Good morning, good afternoon to everyone, wherever you're listening in from, and welcome you to our webinar on biofuels, biomass and energy security with focus on a pathway for Africa's future. My name is Jovia Ogere. I'm going to be your moderator for the session. I'll also be presenting, and I'll be doing this alongside my colleague Sheila, who is going to be helping, taking some notes, as well as our colleagues, Grace and Doreen. We have worked alongside our colleagues, Grace and Doreen from the Africa Energy Services Group to bring this webinar to life. And we're really grateful for the support that they've given us throughout all this. And we're thrilled to have an even more diverse lineup of speakers who have leveraged technology and innovation expertise within the sector, and they will be sharing their insights on various aspects of biomass and biofuels in Africa, including the technology that they have used in different parts of the continent. The potential for integrating biofuels and biomass in Africa's energy landscape to reduce greenhouse gas emissions cannot be overemphasized, and there's need for us to understand the various sources of energy, which brings us to this webinar. So without further ado, I'd like to just introduce some housekeeping rules before we start. I think somebody needs to mute a bit. Okay, thank you. So like I mentioned, the session is going to run for 2 hours. Please use the chat box for any comments or questions. We'll be able to pick them up. But of course, it will depend on the time, but we'll try our best to respond to most of them. Also, please feel free to raise your hand if you need to speak, and we'll give you an opportunity if time does allow. And we also want to let you know that questions will be handled at the end of the session. So we're not going to take questions in between presentations, but before our first break, we'll take questions, and before the end of the session, we'll take another set of questions. We may also utilize Slido just to get some feedback from you, the session, and we shall have a 10-minute break after the first hour. And my colleague Sheila will be our timekeeper and may occasionally jump in to remind us when our time is almost up. So without further ado, I'd like to take this opportunity to invite Mr. Leonard Lebec. Somebody needs to mute again. Okay, great. I'd like to invite Mr. Leonard Lebec, who's the coordinator of LIPRI, to give us a...
You're muted, Jovia.
Can you hear me now?
Yes.
Okay. Have I been audible before, or have been muted
yes,
the
it was
whole
just
time?
for a couple of seconds.
Just
Okay.
5-10 seconds.
Okay, great. So I'd like to take this opportunity to invite Mr. Leonard Lebec, who's right here. He's the one who's reminded me that I'm muted, and he's the coordinator of LIPRI, and he'll be giving us some welcoming remarks and also talk about the LIPRI project, which most of us are part of. And so without further ado, you're welcome, Leonard.
Thank you. Thank you very much, Jovia. Hello, good morning, everyone. Trying to mute. So, yeah, thank you for the kind introduction and for the organization of this webinar. Happy to see that the attendance is quite high, so it's very satisfying. So, Leonard Lévesque, working at LGI Sustainable Innovation, French SME, coordinating the long-term Euro-African Partnership on Renewable Energy. So LIPRI, in a nutshell, is not a simple project, is rather long-lasting initiative that started in 2018 and will last until at least 2030 with the support of the European Commission. So the main assets of our initiative is our capacity to organize joint programming and funding activities involving both funders in Europe and Africa. So we've been organizing 2 calls for project in 2021 and 2022, and currently there is an open call that will be closed in a few weeks. I guess some of you are already aware of that. And we can also anticipate the fact that this co-funding mechanism will be sustained, and we will try to organize a further call in 2026, and I hope also in the future. So thanks to this co-funding mechanism, we've been in capacity to fund at this stage 31 projects. That for the majority are still ongoing. Well, some of them are getting to an end, some are finished, but the portfolio of project is still very active. So we address within this project several roadmaps, thematic priorities, including the recycling, the end of life and second life management of renewable energy components, standalone systems, smart grid, productive uses, clean cooking and modern cooking technologies. And actually, biofuel are a significant roadmap or thematic priority that we address, because at LIPRI level, also with the pool of funders we've been gathering, we are convinced that the development of biofuels in the Euro-African context offer a lot of potential benefits in energy diversification, but also in economic development. Even if these may have significant challenges in their environmental impact or food security, but also governance. So these are the main topics that will be discussed today. We will welcome some projects that are not directly member of LIPRI funding process, but that are active in the wider community of LIPRI. So within the program, we also have been developing a set of services that will be sustained in the future, including the capacity to organize an annual forum that we try to organize most likely in Africa. And also we have a community management platform that some of you, I guess, may know and may use. So we kindly invite you to have a look to the platform, to all the features that are on it. You will see that there are resources related to biofuels, to energy diversification, and other topics related, for instance, to biosecurity, food security. So this tool is intended to be kind of a knowledge repository where experts can share content, document, expertise in a specific field. So I will not continue too long. Just to say that biofuel is a key topic within the current LIPRI approach, and will be sustained as we can anticipate the fact that biofuels, the biofuel sectors, and all the impacts related to the development of economic opportunities related to biofuel development, and also the link with food security and agriculture, will be a key topic in the view of the next call for project to be launched in 2026. So Jovia, thank you for the introduction, and over to you.
Thank you very much for that introduction about LIPRI. I think I've seen some, messages in the chat box. I think there's something about, there's a link on LIPRI, so please do check it out in case you need to follow on the work that's happening there, or you need to join in. Please do check the links. We'll be posting links throughout of the different speakers. Thank you so much again, Leonard, and I'd like to move into it right now. We do not want to assume that everybody who's here today is fully aware of biomass and biofuel sector. So we're going to have a brief overview, and I'd like to share my screen. I'm going to keep this as short as possible because I know there's a great lineup of speakers who are waiting to present. So I'm just going to give a very brief overview of the biomass and the biofuels sector. So are you able to see my screen?
Yes.
Okay, great. Okay. So, like we mentioned, this webinar is on biofuels, biomass, and energy security with a focus on Africa, for Africa's future, especially with energy security for Africa. And that's just my name and my email address. All this information we'll share in the chat box, and you can reach out to any of the speakers today. This is just an overview of the agenda for today, and we're going to try our best to keep time. I think Sheila will be there ensuring that all of us are in time. We have a really great lineup of speakers who are going to tell us about the different projects that they're doing across the continent. Some of them are LIPRI-related projects, others are outside, but it's important for us to know what's being done out there. So for the brief overview, this is just about me. I'm an advocate of the High Court of Kenya. I'm a lawyer, a legal researcher, and also a project manager at the UNESCO Chair for Climate Change Resilience and Sustainability based at Strathmore University. And I'm very much committed to human rights and sustainability in business practices, as well as gender-related matters, and overall advancing Africa's sustainable practices are called human rights and engage in activities that align with environmental and economic objectives. So for biomass and biofuels, like I mentioned, we're assuming that some people here do not know about biomass, and this webinar is supposed to be an eye-opener, so to speak. So biomass is pretty much organic material from plants, animals, and animals used for energy. Trees, when trees are cut down, landfill waste, a lot of the trash that we throw out, a lot of trash that comes from a lot of our activities as well as animal activities, a lot of animal manure. So you find a lot of people who are into farming, agricultural crops like sugarcane. Of course, there's human waste or sewage, which can also be used for producing biofuels, algae, as well as food processing waste. And on the right, you just see a picture of what are the sources that I've mentioned below. Don't worry, we'll be able to share some of these presentations. So if we are rushing through, please bear with us. And then about biofuels, biofuels are derived from biomass. It's from biomass that we get the fuels that we need for energy. That includes biodiesel, bioethanol, biogas, and renewable diesel. I'm not going to dwell so much on this. As I mentioned, it's just an overview. Our other experts are going to delve deeper based on the projects that they're working on. Now, for the sector currently, you find the energy landscape in Africa has very high reliance on traditional biomass. I believe for most of us, especially those who live in Africa, we have we know at least one relative or someone very close to us who still uses wood or charcoal for cooking and heating. And also in Africa, there's now an increased interest in more modern biofuels, especially for transportation and energy generation. You find very many people are now getting more interest in what this is, how we can harness different energy sources that are also more affordable. For the statistics, you see that there's over 600 million people that lack access to electricity in Africa, and that's quite a large number. Many of us are not aware of it because we're used to spaces where we have that power. But if you think through it, a lot of people, especially in the villages, do not have electricity. They are relying on power sources that you would find are an inconvenience. So it's very important for us to have as many sources as possible that are efficient and are affordable. And biomass accounts for about 70% of total energy consumption within African countries. The opportunities for biomass and biofuels include renewable energy potential with abundant agricultural residues. We have a lot of farming. We have a lot of people who are involved in farming sugarcane, maize, palm oil, and all of these residues can be used for generation of biofuels. And then there's also opportunities for waste to energy projects within urban areas. And it can help also with the issues that we have with a lot of landfills within the cities. There's also opportunities for innovation and technology development, which I think is part of what we are going to look at in this webinar today. And also there's opportunities for economic development where there will be job creation in rural areas, for example, through biomass production and processing, as well as a high potential.
You have 2 minutes.
Sorry, okay.
2
A
minutes,
high potential for enhancing energy security and reducing imports. When you look at the challenges that are affecting the sector, it includes sustainability concerns, including deforestation for land use changes due to biomass extraction when trees are cut down because we're trying to get, the trees that we can use, and then the need for sustainable practices to balance energy needs with environmental protection. So these are some of the issues, again, we're going to look at throughout this webinar. Then there's also technological and infrastructure gaps with limited access to advanced technologies for biofuel production, inadequate infrastructure for distribution and processing, as well as inadequate funding for research. Some of these are going to be discussed and hopefully we have a solution towards the end, some of which can come from you guys who are listening in. And we hope you will be able to give us that feedback. And then when you look at the recommendations for the sector to grow, there's need for increased policy support, where we need more clear policies and incentives for biomass and biofuels production. And then also the need for more promotion of research and innovation in sustainable practices. This can come through funding. Then also investment and partnerships, which is part of what LIPRI is doing, encouraging public-private partnerships to fund projects and engaging local communities in biomass initiatives, which is part of what many CSOs can do in this regard. Now, just a run through the objectives of the webinar. This webinar is intended to disseminate the latest research findings and technological advancements, showcasing recent advancements in biomass and biofuel technologies with an emphasis on innovative practices. Then we also want to present an overview of the involvement of stakeholders in the area. We also want to discuss policy and regulatory frameworks that support the development of biomass and biofuel sector in Africa, and also identify opportunities for policy engagement. I see Sheila is trying to kick me out, so I'll rush. And then also provide recommendations towards overcoming existing barriers in the development of the biomass and biofuels energy sector, focusing on job creation and creating a platform for stakeholders. So please take as many connections as you can from this webinar. Don't go away with nothing. At least reach out for connections. Thank you very much, Sheila. And that's it from my end. I think I'll stop sharing and then I will jump right into the next session. Sheila, I hope I didn't take so much time.
It's fine.
Okay. So our very first speakers, our very first speaker today among our experts is Mr. David Jesse, who is the CEO at Green Drive East Africa Limited. He's a senior advisor at the Kenya Biogas Stakeholders Network, BioNet, and director at the Nairobi City Network. Mr. David Jesse is going to discuss policy frameworks and regulatory challenges for biomass and biofuels in Africa. And without further ado, you're welcome, David. Please take us through. Thank you.
All right, let me get my presentation. All right. So good morning and good afternoon, our viewers and participants. I hope you can hear me properly. Am I audible?
Yes, you are.
Thank you very much. And thank you, Jovia, for the wonderful introduction of the subject matter. I think for those of us who are perhaps not interacted much with the bioenergy space, at least got an idea of what you're talking about here. And my brief presentation, just about 10 minutes to go, is to assess Africa's policy and regulatory frameworks in delivering sustainable development and energy security. And of course, our focus here is on biomass and biofuels resources. Just a brief introduction of myself. Yes, as Jovi has mentioned, I've got a private company where we deal in bioenergy products and services, as well as mostly in policy interactions, and also trying to collaborate various stakeholders and trying to form coalitions that help drive the topic in Kenya and even East Africa in general. I'm also holding up as the senior advisor to the Kenya Biogas Stakeholders Network, which is a formation that has brought together biogas practitioners in Kenya, both policy makers as well as private sector players. And the whole thing is that we try to create harmony within the sector and try to do some bit of self-regulation, but at the same time try to promote policy around about the bioenergy and specifically on the biogas technology. Something about other areas that are also helped in trying to formulate certain policies are the Kenya National Industrial Training Institute, Institute, and also the Biogas Technical Committee at KEBS. Now, just look at a brief headline on what we are going to look at. Just to have a quick overview of biomass and biofuels, look at what are the current policy landscape that we have. I'll look at Africa as a whole, and especially the regional economic blocks. We'll also look at some of the barriers to developing legal frameworks, and especially in deployment, and then also look at some recommendations that we can have to enhance policy improvement, as well as venture into areas that can improve the environment and the sector of bioenergy as a whole. Just a brief presentation on what we're doing in Kenya as a case study. And of course, we are looking at certain keywords here. I think we all understand when you talk about sustainable development, when you talk about energy security, and also the other issues of regulatory frameworks. But I think what I'm trying to emphasize here is that the development needs require policy formulation. Once we identify what the development needs are for a nation or for a continent, then we need to get policy formulation. But this policy formulation, whatever policy sets that we have, must have certain legal frameworks to kind of like bring them to life. But then without proper enforcement or motivation for stakeholders to be able to make use or consume these policies, then it amounts to nothing. But then as we use the policies, of course, we have what we call consumer experience, either to improve your business or to try to improve the landscape for the private sector or for communities engagement. But then once we get this experience, there should be feedback. There should be some kind of a loop between the needs identified leading to policy and then legal frameworks, and then finally to the consumer experience, which then should be able to give us a glimpse as to how can we better the policies. So just to have a quick overview of the biomass and biofuels productions in Africa, I think Jovi has already mentioned that some of the resources that we have for bioenergy, forestry biomass, agricultural waste, organic municipal waste, algae, as well as energy crops. But in the African continent, you'll notice that if you look at the if you look at the continent as a whole, we are contributing about, we are depending about 47% of the population are depending on the solid biofuels. But you look at the south, in southern Saharan Africa, with South Africa considered, these are some of the figures that we get from the EIA. We have about 61%, but you see how this figure shoots up very quickly when you exclude South Africa, so that we come to about 81% in the Sub-Saharan Africa. But then you'll also notice that the contribution for the renewable energy, that was, according to AIA statistics, we have an average of about 55% of bioenergy as part of renewable energy, and about 6% of global energy supply in terms of what biomass is actually contributing. Now, in 2022, we had 1.9 billion cubic meters of wood fuel, which was produced globally, and Africa and Asia actually topped that particular share with 37% each. So you can imagine, the role that the biomass is is playing in Africa and of course in Asia. And then if comparing Asia and Africa, Africa is only second rate with 26% of global bioenergy. But then if you look at the production of electricity, we only have like 0.3% that's coming from, from biomass. But we need to remember that a lot of consumption of biomass in Africa is for heating and also for cooking. So there's a lot of issues around cooking area. In fact, when you talked of your figure of 600 million, that is for electricity. It comes to about 1 billion for those who do not have access to clean cooking facilities. So there's this thing about traditional bioenergy uses vis-a-vis advanced biofuel production. But if you look at the whole ecosystem, the biomass to biofuels to bioenergy is a whole value chain that sometimes leaps from the traditional to modern usage. Anyway, let me proceed. Having given a brief overview of that, I believe we shall take any questions on that later. Now, the current policy landscape in Africa for bioenergy, it starts from the Africa's Agenda 2063. Now, that agenda runs through a number of issues. And of course, the whole idea is to get certain frameworks for development for Africa. But then you realize that this development is going to require a lot of energy in order to get to some of the, for example, if you look at the integrated high-speed train network and also the recent introduction of the continental free trade area, and even if you want to silence the guns, for example, that the agenda is looking for, a lot of fightings and resources, even the DRC Congo that you see right now, is largely about resources. How do you control these resources? So in order to make these things possible, we need to manage our energy portfolio. And so Africa is going to have to develop what we are calling the Africa Bioenergy Policy Framework and Guidelines, which was launched in 2013. And the whole idea was to try to harmonize sustainable bioenergy development in Africa. Under this, you'll find that it plays very differently in other places, especially in the in the regional economic blocks. For example, ECOWAS have got a general bioenergy framework, what they call ECOWAS bioenergy strategy. East Africa is not developed one like that for ECOWAS, but there's a lot of collaboration through the East Africa renewable energy and energy efficiency. So you'll find a lot of work going on in some of these renewable energy blocks, or rather the regional economic communities. And there's a very big attempt to try to promote these bioenergy concepts. But then also, you remember that we have quite a number of regional power pools, which are also coming up. And the whole thing is that how do we achieve the interconnectedness of Africa, given the vast amount of resources that we have for bioenergy production? We see some effort that was being done by the EU Energy Initiative Partnership that helped a number of countries develop their biomass energy strategy, as they call it. For Malawi and Rwanda, these are complete. There are some which are ongoing for like Ethiopia, Mozambique. Kenya did develop its national bioenergy strategy in 2020, but with the help of GIZ, as well as the EU to some extent, not really under this Energy Initiative Partnership. Sorry?
1 minute, sorry.
Okay. So I'll have to dash with my presentation. So some of the barriers to deployment of legal frameworks is, as you can watch there, the policy and the strategy and action plans are actually not very, if you look at across Africa, you find that somebody can develop a policy, it takes another like 5 years before you develop the strategy. Like I can cite an example for Kenya. We had our policy developed in 2020, and the strategy came back, and the action plan came in 2023. So that disconnectedness is a big issue. the matter of having a lot of regulations but little enforcement, and also the issue of over policy. There's a lot of policy that has been developed. In Kenya alone, for example, we have over 15 policies connected with bioenergy, but very little enforcement, as you can see. So that's a big problem. Of course, the issue of political will and high-handedness in terms of doing some of the things without resorting to policy are also a big deal. Recommendations of policy improvement. Time is up. Can you add me just 2 minutes, please, kindly? Just to wind this up. So we have recommendations of policy improvement. Number one is the alignment. We should be able to align our national goals and aspirations. And I want to propose strongly that we need to look at the net zero 2050. So a lot of these policies should align themselves to the milestones which are also provided there. Also look at the SDGs. But most importantly, when we have unified policy frameworks, like under the regional blocks, and especially now under the Africa bioenergy framework, that is very, very critical. And look at the issues of food security versus energy access, but focus more on agricultural residue and agroforestry. If you look at ISO 13065, that's talking about bioenergy guidelines. I think that's also very critical in terms of looking at those areas. But we need to focus on rural access, productive use of energy, as well as the food energy balance, like I mentioned. So what we are doing in Kenya, there's a lot of activity happening. The CSOs and private sector have actually come together in a very strong way and are pushing the agenda of bioenergy. We have developed what we call the Bioenergy Roundtable that meets almost quarterly, and we have a lot of input into the bioenergy processes. We have the annual Bioenergy and Clean Cooking Week. We also have the African Bioenergy Partnership that also been formed as a private company, more or less, doing what is trying to promote from that angle. So we see a lot of happening in Kenya, and we hope that this can also be replicated in other parts of Africa so that the bioenergy agenda is driven by the CSOs and private sector collaborating closely with the public sector. I think I'll end there and perhaps answer more questions later on when they come. Thank you very much, Jovia.
Thank you so much, David. Sorry for rushing you, but because of the time, I think we'll be able to save some time for questions. And thank you for the discussion on what Kenya is doing and also for the insights and the recommendations for, improving the legal framework that it can work for the biofuels and bioenergy sector. For me, I think what I've mainly picked is the alignment, which I think is very important, as well as collaboration, and which is part of the work that we're trying to do. But just so we save up on time, I'd like to get into the next conversation. And this is going to be led by someone else also called David, but his name is David Vera. And David is going to discuss the optimal integrated waste management and energy production systems with focus on leveraging agri-food waste for renewable energy development. David is a PhD industrial engineer and an associate professor in energy and electrical engineering in the department at the University of Jaén in Spain. And he will be leading us through this. Very welcome, David Vera.
Good day, Jovia and the rest of the team, the participant. Can you hear me?
Yes, we can.
Okay, I'm going to share. It is necessary to stop sharing the screen of other David or not necessary?
No, I think David will need to stop sharing.
Okay.
David, Jesse? Okay. There we go.
Okay. Can you see my screen?
Yes, we can.
Okay, let me put in full screen. Okay. Hello everybody, good day, good morning and good afternoon. I'm David Vera, as Jovia has said. I'm a researcher and associate professor in the University of Jaén in the south of Spain. I'm going to talk about REFEC Africa project and the 2 case studies about optimal integrated waste management and waste to energy system in Africa. Talking about a little bit about the REFEC Africa project is a Horizon 2020 project that started in 2021 and finalized in 2026. It is 5 years. We are 31 partners from 11 countries in Africa and 5 countries in Europe. We are 3 three clusters, okay, one in the north, one in the west, and one in the south. And we are more than 100 researchers, and more than 40% are women. Okay, so the objective of REFEC Africa, it is not a LEAP-RE part of the LEAP-RE project, but it is a cooperation with them. And the objective of REFEC Africa is, at the end, to validate and install 3 waste-to-energy technologies in 3 countries of Africa. One of them in the north, in Morocco, in Ghana, in a rural area, and in South Africa. Another objective is to perform a life cycle assessment of the demonstrator before and after the solution, and to establish 3 living labs on the site to promote, to boost the technology for the stakeholders and also the research and academia. Okay, the system is focusing on the waste valorization of agri-food wastes. We can use solid biomass from different agri-food value chains, almond shells, we can use peanut shells, cashew, cottons, maize, and we are going to use a waste-to-energy technology that the name is gasification, and we can produce 3 byproducts. One of them is electricity, the other one is heat, and the other one is a charcoal, biochar that we can use for soil amendment or, for example, for clean cooking. Okay. The waste, I'm going to talk about a little bit about waste-to-energy technology. The objective is biomass gasification. The technology is a mature technology that converts a solid biomass in a green gas. The name is synthetic gas, and it is composed by hydrogen, carbon monoxide mainly, and another no fuels like carbon dioxide and nitrogen. Some key types about the technology is the cost is around 2,000 euros, between 2,000 and 3,000 euros per kilowatt electric. We need a biomass requirement. It is very important for this kind of system. We cannot introduce directly the biomass as raw. We need a pretreatment that some or less is 50, 60 maximum of length. The maximum moisture content is 20%. And the surface needed for the demonstrator, for the plants, is, for example, is an average number. For 100, 200 kilowatts of electric power, you need around 200 square meters. Okay. And now I'm going to show you the 2 case studies that we developed in REFEC Africa about the biomass waste-to-energy success case study. In the right side, you can see an overview of 2 plants that we have here in Spain as pilot plant. Here in Spain, we make training to the African partners, and after that, they go to the countries and can start the installation and commissioning. In Ghana, it is a rural area. There is a small village, is Tuna, and there is a school of children that the condition and the situation is not very good because they have a lot of lack of electricity, many blackouts. Very important for us, there is no access to drinking water, to fresh water. The only source is underground water. Another thing that also happens on the site is a very high unemployment rate. Only people works in agriculture sector. And at the same time, there is a large amount of wastes. So REFEC Africa tried to create a synergy between agriculture, water, and energy streams. Okay, this is some picture of the village on the site. The school has more than 1,100 children. We have some computer labs that normally they cannot use due to electricity lacks. And on the site, we work with an NGO that the name is NASCO. Tuna is located in the north of Ghana, and it's a rural area. During the installation and commissioning of the plants, we spent around 6 months, starting with a platform, with a structure, biomass power plant structure, PV system, and this is a screenshot of the current situation. Now the current situation is like this. Okay, what is the composition of this microgrid? So this microgrid is composed of PV system, 24 kilowatts peak with a battery system of 84 kilowatts per hour Fluon battery. The system and the power plant use peanut shells, has raw, and directly without treatment, and we can produce 20 kilowatts of biomass gasification and add electric power. The biomass consumption is around 30-35 kilograms per hour of peanut shells. Also, in one of the rooms of the buildings, we are going to install a tap water, drinking water system that they are going to use the electricity to produce water system. This is the current view today. we have made some improvement because we need to homogenization of the biomass due to the peanut shell. The density is very low, and we install a pelletizer for the densification of the biomass. And now we are working in training because we understand that training is the most important part of this kind of project, because we suffer a lot of capacity on the site, technical capacity, and training for us is the most important for the success of the technology and the project on the site. Okay, what is the impact on the site? Okay, so we can produce 40 kilowatts of electric power. The technology is PV battery and biomass gasification. The system can operate on grid and off grid. The demonstrator can use local biomasses, has, for example, peanut shell and cashew shells. We have created 10 indirect jobs during the installation and commissioning, and now we are creating 3 direct jobs during the operation and maintenance. Also, the drinking water plant production is going to produce between 6,000 12,000 liters per day of tap water, of drinking water, for the necessities of the local families in the school. Okay, so it is the situation of the Ghana demo. And another waste to energy success case under the REFEC Africa framework is the demonstrator of Morocco. In Morocco, normally the agricultural sector is focusing on, for example, in the olive mill, there is a lot of drawbacks. For example, there is a lack of power supply. All of the mills operate in off-grid with diesel generators and generate a lot of pollution. The electricity costs and the energy costs are higher. They produce a lot of wastes like prunings, like pomace, and the PV technology is not a solution due to the cost, also because you need batteries, and also for irrigation, it is impossible to irrigate during the day due to the high temperatures during the day. So looking for a solution, okay, this is the overview of the scheme. Currently, in the past, the olive mill operates with diesel genset, totally fossil fuels scenario, and now we are going to convert the system to a gasification. Okay, so the general concept of this demonstrator is to install a gasification plant of around 70 kilowatts. The total installation time was 6-7 months. This is an overview of the steps that we developed in the last year. We finalized in December of 22 months ago, and the system is going to produce electricity for the mill, thermal energy that we are going to use in the future for drying process of the biomass, and biochar that we can use for the soil enhancement of the olive trees on the site. Okay, you can see here some pictures about the power plant already finalized, some testing of the site, and the performance data that they are going to produce is 60-70 kilowatts of electric power, and a biomass consumption of 775, and biochar production of 12-15. Okay, this is the performance data and key performance data of the waste to energy technology. To finalize the presentation, I would like to say the benefits for the agri-food industry in Morocco. They are going to produce 100% of renewable electricity. They can manage their own byproducts. They are going to generate new value added for farmers, is biochar and compost. We are going to create technical jobs on the site because the plant needs 2 technical operators, and they are going to reduce very hard the carbon footprint of the value chain of the olive oil, replacing 100% of the diesel by biomass. To finalize the presentation, I would like to focus in the barriers, okay? Because I would like to comment. How many times? 1 minute?
Yes, 1 minute.
Okay. Okay, I finalize in 1 minute. The most important barriers that we have suffered mainly in Ghana is this, okay? The technical barriers to develop this kind of system in this kind of countries, for example, in Ghana, we are suffering some technical capacity on the site. It is difficult because it's a rural area. It is difficult to look for electricians, welders, plumbers, and it is not easy to install this kind of system in these rural areas. It is difficult now during operation to get spare parts like lubrication oil or filters or chemicals. Also, in the capital, not in big town, but in the rural areas, the capacity building is not the best. So we need to be a lot of efforts with the big cities. And one important thing in Ghana is the bad condition of the roads and the electrical network. Okay, for example, Keita, when you travel to Ghana, the distance between the Accra is the capital to the rural area is around 600 kilometers, and the time is around 15 hours by car. So if you need to buy something in the capital, you lose a lot of time in this, a lot of many gap. A lot of important barriers in policies, in Ghana, high custom cost, there is a lack of renewable energy, and the electricity that you produce in the plant today, you cannot get revenues because there is not an important framework to promote the renewable energy plants on the site. Another cultural barriers is communication, for example. Communication in Ghana is in the cities, in the big town is very good because it's English, but in rural area, in Ghana has 18 official languages and 45 unofficial. So communication is not easy, and we need the support of another partners, universities, and this is the most important barriers that we are suffering just now. Okay, thank you very much, and you can if you have any questions, you can discuss more about that in some minutes. Okay, thank you very much.
Thank you very much, David, for that insightful presentation, and also for the work that you're doing in Morocco and Ghana, and for the opportunities that you've availed to the locals, as well as the technology access towards reducing the carbon footprint. Again, Sheila is on all our next, so I'm just requesting all the presenters, if you see Sheila's hand up, it's just a warning that time is almost up. But now, this is just a mere coincidence. We didn't plan this, but our next speaker is also called David, but Dave Lelo. And Dave will be speaking to us about the smart home energy, which is called SHE, which specifically he'll be talking about the development of an integrated and mobile solution for low-cost cooking and power generation. Dave is the CEO and visionary leader at Ekasi Energy, and he's an honorary board member of the World Bioenergy Association. Dave, welcome, and please go us away.
Morning, is the share working?
Yes, you can see the screen, Dave.
Thank you. Morning, everyone. This morning I'd like to discuss some of the areas that, and thanks to the speakers before us, I'd like to discuss areas around cooking and household energy. I've been working in this area for over 10 years now, and I'd like to just give you a quick background on what the things are. Just as an introduction, SHE is a project within DeepRe, and it's looking at using clean energy from crop residues using gasification, microgasification. This is the first project, I believe, that has a first comprehensive study to look at crop residues. Many people talk about crop residues, but many of them are not feasible for use in cooking because of certain gases and chemicals in them. And so this is a project to be able to look at comprehensively across Africa and find out which crop residues are suitable to cooking. The project entails a number of partners, which you can see there. I'm not going to dwell on that. I'm going to go into the issue of crop biomass residues. Today, as you see in sub-Saharan Africa, 80% of cooking fuels are used, by David earlier, are used with biomass. Now, there are three issues with this. The first issue is that the stoves that are used have a very, very low efficiency. They have a low efficiency below 20%. It means people are using twice the amount of biomass they should. Secondly, when they make charcoal, all of the heat from charcoal is wasted. It just sent into the air. Thirdly, when people use need their crops to be planted the next year, they just burn their crops. So you'll find that although we have a high level of crop residues and energy available in Africa, they're not really being used smartly. They're being used in a very wasteful way. And as we increase our population in Africa, there's not enough biomass to be able to sustain it. So one of the things we've looked at is to take crop residues. Let's look at these maize stalks. They're normally burned after a harvest. If harvested, we've done this with 300 tons in Zambia last year, you can actually compress them, make them into fuel, and then sell them as a household fuel. This provides two things. One, it reduces the need for charcoal, and two, we actually bought this from the farmers, so it provides the farmers with additional income for what they've grown. As I've indicated, the crop residue burning is a very harmful practice. It increases PM 2.5 levels, makes it very unhealthy for the people in the area, and thirdly, it degrades the soil. And if burnt in the correct way, it can be turned into biochar and put back into the soil. It just needs a small adjustment into the way that it is burned. So we are promoting a process where recycling lignocellulose residues into solid fuels is better than just burning it. The residual leftovers for the biochar can be used back into the soil to add the soil. And I will show now how smart value chains are using to be able to re-engineer the cooking value chain in Africa. So we believe that if we look at the crops that are made, 70 to 85% of those crop residues of the volume is crop residues. Some of that's fed to animals, some of it could be made into heat, some of it could be turned into biochar and fertilizer, which creates a circular economy and conserves the material as well as creating valuable heat. This is just an example of different residues. And as I said, we are analyzing over 20 different residues to find out what is available. And in a country like Zambia, there are over 2 million tons of residues available from maize. This is a picture of a factory that we have set up in Cape Town, where we manufacture parts for stoves, and then we ship those parts into Africa. We have micro factories in Malawi, Zambia, and Mozambique, where the stoves are made. These are 100% produced in Africa from South African produced stainless steel. No need to import anything from China. Additionally, we in the SHE project are working on a process where we can actually report the usage of the stove. By reporting the usage of the stove, we create a database so that we can understand the behavior of people and how they're cooking. And we hopefully on that are able to then also claim carbon credits in ITMO programs, which are country-based carbon exchange programs between the global north and the global south. So what are the advantages? We preserve what nature has created. We want to turn that waste into energy rather than burning it. We want to improve the smallholder well-being by providing them with the ability to put biochar back into the ground, as well as paying them for those additional income streams for residues. And we believe that by using the stems and straws, we actually improve the clean combustion, because the gasified stove that we produce burns a lot cleaner than burning wood or charcoal. This is just an example of a feasibility we're doing in West Africa, where there's palm oil and a lot of palm oil waste. And you'll see that smallholders have small areas. Currently, they just dump and burn the waste after they've made the palm oil. This is an opportunity for us to recycle. And that's an opportunity you can see in terms of what a profit it would be. So in any of this we're doing, we're looking at a profitable opportunity and not a social enterprise or anything like that. We believe that by recycling crop wastes into these products, that they will produce a profit opportunity. This is just a quick look at where we've been, where we started this program with SHE, and we believe that by the end of SHE we will be able to correctly identify the areas that are able to be added value to and the markets that are profitable to us. And we thank Libri for the opportunity. Thank you.
Thank you very much. Thank you very much, Dave. That was right on time. I think you're the first speaker to finish in time. Thank you for the wonderful presentation on the work that you're doing, especially in the southern part of Africa and, you know, everywhere that you're trying to move, because you've talked about West Africa and palm oil. And I think it's very insightful for all of us who are here today to understand that actually crop residues can be used for clean fuel. And so that's very important. And thank you so much for that. I think now we have just a few minutes to take some questions. I don't know if my colleagues have picked up on any questions in the chat box, or if any of you in the meeting today, in the webinar today, have any particular question for any of our presenters today on any of the aspects that have been presented. Please do raise your hand and we'll let you speak. But you can also post your questions in the chat. Oh, I see a hand up from Matthew. Yes, Matthew.
Yes, I have a question for David Jesse. And it is, what can be the role of public university and the public research institute in Africa to help to develop the bioenergy systems locally in Africa? And how can you think that networking can take place in a win-win situation with the people in rural areas and also the private sector? So, but in short idea about this, if you have.
Okay. David Jesse.
I think the potential for universities and other public institutions to come together in a matter of trying to pool know-how as well as experience is very, very critical, but especially in setting up the bioenergy institutes. I think for me, it is up to the AUC, the AU to begin to think seriously about bioenergy prospects and create the necessary mechanisms for that. And indeed, I didn't see that feature prominently or strongly in the bioenergy framework and guidelines given, but I think that is something that should be pushed. In Kenya, what we're doing currently is that we are trying to push the government to implement the bioenergy strategy, and the CSOs and private sector, and indeed the private universities and also public universities have come together under what we are calling the innovation platform. Now, we believe that if this is escalated at Africa level, the innovation platforms can create a very good opportunity to begin to realize what you may term as research institutions or bioenergy institute for that matter. So definitely agree with you. That is an area that we need to look at critically if we are to sustain the future of bioenergy in this continent. Thank you.
Thank you, David Jesse. I hope, Matthew, that has been answered. I want to take one more question. I see Joseph Ojala has his hand raised. Joseph, please unmute to ask a question, and then we'll run into a 5-minute break. It was supposed to be 10 minutes, but due to time. So Joseph, please do ask a question.
Well, thank you very much. My name is Joseph Onjala from University of Nairobi, Department of Economics and Development Studies. And I may be hearing about some of these networks, particularly in Kenya for the first time. And we offer a postgraduate course on energy policy planning and development. And it would really be beneficial if we are looked into the network so that we can, inform also the teaching of the related courses. Thank you very much.
Thank you very much, Joseph, for that. And yes, the networking today is very essential, and we'll be able to share contacts of all those speakers today so that you can reach out and connect with them. So because of time, I want us to transition to our next segment. Let's just take a 5-minute break. We apologize. We are cutting the break from 10 minutes to 5 minutes so that we can jump into the next session because one of our speakers needs to leave early. So let's take a 5-minute break and then we'll take other questions after the next session. Thank you.
Dave, if you could please stop sharing the screen. Thank you.
Thank you.
You want to talk? No. Then limit. Hapana, sasa pia mute yako.
Right. Hope you're all back from a short 5-minute break, and welcome back. As we jump into the next session, my colleague Sheila is going to take over. She'll introduce our next speaker. So without further ado, I'd let Sheila take over. Sheila, if you're able to, okay, there you go.
Thank you. I'd like to introduce our next speaker. Matthew has built an impressive career in bioenergy and agriculture. He currently serves as the technical manager of the Lipri Vil2 Bio project. Today, Matthew will present us on recommendations towards overcoming barriers in the development and use of biomass and biofuels for energy. He will be joined by collaborating speakers, Joan Halifa, Abdirahim, and Pride Ebile. Welcome, Matthew.
Thanks a lot, Sheila, for the short introduction. Can you hear me well? Because I'm not sure about my internet connection since I'm in a mountain area.
Yes.
Everything good? Okay, thanks. So
Yes.
thanks again for introduction. Thanks again for allowing me to speak. Could you share my slides maybe on the screen, because my internet connection will not be enough to put the slides on screen as we agreed before, because I don't see it. So if you can find my presentation. Yeah, thanks a lot.
Can you see my screen?
No, there's a bit of a lag, Sheila. So let me try. Okay, now it's
I
okay.
see it now.
Okay.
Okay, so let's proceed slowly then in this case. So yes, my name is Matthew, and together with some of the colleagues, we are going to present our Lipero project, though it's a collective project, so there are like about 50 people involved. So I hope that everybody knows that we are speaking for them. So the overall topic is integrating biomass into circular economy models, opportunities for African countries. And we look at this topic through the lenses of our own project, Lipero Vil2Bio, from the Lipero program. Next slide, please. Can you go to next slide?
Sorry, Matthew. I think Sheila is having a bit of a technical issue.
Okay. Okay. It's just lagging.
Yeah.
So okay. So then my name is Matthew, and I'm working now from the goat farm of my parents. So that's why. Okay, you can stop this slide. It's good. So that's why my internet connection is not so good. I need help to put the slides on the screen, because otherwise I think I will be lagging even more. And I'm working on a voluntary basis to support the development of research projects, and many of these projects are together with Africa. And before I worked in different countries like Germany, like Greece, also a little bit in France. And now my main work is to be a goat farmer, and my passion is to be a researcher and help to develop some projects. So you can go slowly to the next slide, slide number 3. And slide number 3, I can already start to introduce. Yes, these are my colleagues, some of my colleagues. So there is Pride Ebil from Cameroon, who is working now in the USA and also working remotely together with ZAF Institute, an institute about agriculture in Germany. There is Joan Khalifa, who is working at the Kenyan Industrial Research and Development Institute in Kenya as a researcher on bioenergy. And there is Abderrahim Solhi, who is independent researcher from Morocco, and now is a guest scientist at Technical University of Hamburg, called TUHH, in Germany. And there's experts are helping in our project. So the member of our project, together with these invited experts, also from Africa. So you can go to the next slide. Yes, thank you. This is overview of our project consortium. I will not go into the details because you can find after our meetings probably the PDF files that will be given to you. Basically, we have research institutes working together with a large company, with a small enterprise, with university from different countries. Like it's a North-South collaboration project. So we have, as a North country, we have France and Germany, and as a South country, we have Algeria and Kenya and Morocco. And we are very thankful for the LIPERA program for funding us and also inviting us to talk about our project on the topic of bioenergy for Africa. Basically, this project, the coordination is funded by the European Union, and the national funding is funded by every national agency in the respective countries, like ANR for France, PICYOT in Germany, and so on. And the African countries are funding is organized by AGI, channeling, I think, funding from the European Union, if I don't say mistake. And the other project leaders, you can see their name here. So you can go to the next slide already, so that we can go into the topic directly of circular economy. So the name of our project is combining large village-scale biogas production with pyrolysis in biomass stoves for off-grid sustainable clean cooking and coal production. So it's a complicated name. I will try to explain a little bit. So basically, we start from the waste. There you see we have different type of waste, digestible waste and non-digestible waste. Like non-digestible waste is like woody biomass, you can see here. The digestible ones, we can have manure. Olive meal effluent is an example. It can also be coffee waste in some case, but just an example can be olive meal effluent. And of course, food waste. So in the context, we can test of our project, we might focus on olive meal effluent, but any kind of digestible waste can be useful for the production of biomass. So stay in this slide and just click a button to make the next thing happen, appear. Sorry. So if it happens, like just click one button, because then I have an animation. You hear me?
Yes.
Yes. So anyway, I can already start to explain. So please click, if it's possible, click one button and yes, thanks. Okay, good, perfect. So this is the non-digestible residue can be used for pyrolysis, and with pyrolysis you can produce biochar and you can produce heat energy during the process. And the heating energy during the process, I will explain it in the next slide, some next slides. And with the digestible residues, you can use a biogas reactor that produces some digestate. You can separate this digestate into solid and liquid part. And the liquid part, you can use it for microalgae cultivation, which is also a kind of biomass, like biomass from the water biomass, not soil biomass, the terrestrial biomass. And this microalgae is also a very valuable biomass resource that can improve the quality of the fertilizer in mixture together with the biochar. And with the biogas, it's also a very important source of energy, especially for the idea of clean cooking, because biogas is very clean. So with regard to pollution, it's a very clean way of cooking. So you can clean the biogas using simple technology like water washing. We'll just wash the biogas with water. We're trying to do that in our project. Then you obtain clean biogas, and this biogas you can use it in a gas engine. Otherwise, you can use directly some of the biogas in the biogas stove. And in this case, you don't need to clean it so much. You clean it only a little bit is enough, and then you can use it for cooking. I will show it also in some next slides. If you produce electricity locally in rural area, you can use it for coal production as well. Like this is very important for Africa to keep the food for longer time. Yeah, thank you. So this is an example of the. Yeah, okay, you can go next slide. It's okay. Yeah, you can go to the next slide as you did, and then I will talk about the biomass host potential. So when the next slide, yes, thanks you. So this is an example, a small example, because talking about biomass potential in general in whole of Africa will be very difficult. So this is a small example from our colleagues from Algeria, who are in the project, a center of for renewable energy development center in Algeria. and they send us part of this article, and then you can see an example how you can evaluate the potential. Like you can see how much waste you have, urban waste, like organic fraction of household waste, like the organic part of your waste that you have in your home. You have the sewage from the wastewater treatment plant. When you have a water treatment, you clean the water in the big city or in medium city, and then you can collect a lot of sludge. This is the solid part after the cleaning of the wastewater. This can also be used for the biogas production. This is our example is about biogas production right now. And you can use this Anurka. These are some waste from the olive oil industries. They can also produce some electricity. The pomace also residue from the olive oil industry can also produce some electricity. And then in the end, you can produce electricity. You can see the total amount of electricity in gigawatt per hour. You can convert it based on continuous power on an electricity power. So, for example, using this kind of weight, we could produce theoretically about 194 megawatt, about 200 megawatt of electricity in the context of Algeria. So just you can click to make a next thing appear, or same slide, but you click and something should, some text should appear. On the right side, I should not have animated these slides. Yes, thanks. So these are the other potential resources that are not investigated here. So this could be like the topic of a next presentation with more time available. This could be agricultural effluents and residues like manure, straw from the agriculture, agro-industrial effluents like from the food industry, like sugar, food, vegetable, coffee. I didn't write it. Coffee is important for Africa, chocolate, and so on, banana, so and meat industry. All of this can be used to produce biogas. Even the sludge can be.
Matthew, sorry
Yeah.
for disrupting. You have 1 minute because Hugh needs to present, and then maybe we can pick it up after his presentation. Thank you.
I was too long again. So okay, then firewood and investigating all these sources. So next slide. If you can go to the next slide. Let me check. So this is basically the equipment we are building in our project. You can see the reactors that are pyrolysis reactor that can be built in Kenya. You can see microalgae raceway that can be built in France. You can see microalgae experiment in Algeria. You can see a design of a biogas reactor in Morocco. Simulation of a pyrolysis cook stove in France. You can go to the next slide already. So because yes, you can switch already next slide in order to gain some time. So this is the different biogas systems you can find in Kenya. This is a study done on field study done by colleagues from the University of Nairobi together with Kenya Research Development Institute in Kenya. You can see some flexible bag reactors. You can see some fixed dome reactor, a floating drum biogas reactor, different system of bags that can be built directly in rural. You can click, just click to same slide. And you can see after some time, there is a biogas burner that can be used. From the biogas, you can use the biogas in a biogas burner. And then if you click same slide again, you can see that you can use the effluent as a fertilizer, for example, for vegetable production. So this is the circular economy idea. You produce not only energy, but also fertilizer after the biogas digestion, that is a biological reaction that produces this biogas. And digest the organic material. Then you can click again and the phosphol, and then you can see that there is you can click again. Freestone, same slide, freestone olive. Yes, exactly. There is traditional technology for cooking. Problem is pollution. Problem, you need to use firewood, so deforestation. If you use more advanced technology, you can resolve this problem. You can have carbonized briquettes or non-carbonized briquettes. So carbonized means you convert them into biochar. So next slide. Okay, so you can click again to make things appear on this slide. So basically, you have the infrastructure in Africa. If you combine this infrastructure together with the socio-economic expertise, so in case infrastructure provided by the Kenya Research and Development Institute, together socio-economic expertise from the University of Nairobi, then you can implement the technology in Africa. So okay, you can keep this slide is good. Next slide. Okay, you can go already next slide. So these are more details about the Kenyan partners who attended the meeting in France and Italy, and thanks to the program. So basically, the challenge of our project is communication between many different stakeholders, African researcher, invited expert, European researcher, companies, African companies, and maybe other stakeholders. Then you can click again to make things appear on this slide. And you just, in a short, yes, these stakeholders have different ways to communicate and they have different interests. So the difficult thing is to make them work together. So you can click again to stay in the same slide. And you can see that some stakeholders are included. Okay, you can stay in this slide, so it's not, yeah. Okay, some stakeholders are included in our project and some are not included yet. So we have to go in next projects maybe, or try to reach out to this stakeholder and see, find a way maybe for the next project. So you can go already to the next slide in order to gain some time.
Yes, your time is already up, Matthew.
Yes. Okay. So, but yeah, okay. Let's go. Yes. Okay. This is important though. These are the scientific articles published on the topic of biochar. So you see that Africa started with 1% of articles, now up to 5%. So Africa is growing in terms of scientific production. The market for cook stoves in Africa is only 4% of the total in this case, but probably it will increase in the future. So Europe and America, we have to collaborate with Africa because you see Europe and America are decreasing while Africa is increasing. So they are key to work and collaborate together. So we go next slide, and it will be the final slide. So final slide, and just display the next slide. And the next slide will be an example of Anila stove called TLUD biochar cook stove. If you go next slide number 12, and if you can put it on the screen, but I can already explain it. So this is a reactor that I already presented previously, and you can combine the production of biochar and this reactor together with the production of energy for cooking at the same time. So if it doesn't display, yes, exactly. So this is an example of this reactor, same as in Kenya, but built in the Ethiopia. So that means that the expertise in Africa is growing with regard to this kind of technology. In the middle, you can burn the wood and you can produce cooking energy. And in the outside ring, you can produce the biochar. And that's it. Thanks a lot. Bye-bye. Thanks a lot, everybody. I'm sorry for all the time.
It's okay. Thank you, Matthew. I apologize for rushing you, but Hugh is coming in next and he's rushing somewhere else. Please allow me to welcome Hugh, who is the founder and director of Steam Bio Limited and Network New Europe Limited. And he's going to be presenting on using a superheated steam process to convert invasive biomass into clean burning solid fuel. And also perhaps give us some recommendations towards overcoming some of the barriers maybe they have experienced or some of the other presenters have experienced. So without further ado, I'd love to introduce you. You're very welcome.
Thank you. Thank you for the introduction. And without further ado, if you can bring slides up, thank you, because my dentist won't wait. Okay, so if we can put the full screen up, far away. So this is an overview who I am. I've been involved in EU and other funding probably for over 40 years. And in that journey, I came across technology. So if we go to the next slide, which is the basis of the work that I've been involved with for probably about 15 years. Excuse the dates being wrong. So if we move on to the next slide to hide my embarrassment, and I'll talk really on the time scale. I first came across enabling technology over 25 years ago, leading to first EU project using superheated steam, continuous superheated steam as a drying technology. Unfortunately, it became lost in that cycle of further research projects where it was driven by research performers rather than a market need. Doing research is great, but sometimes it can get lost by finding where's the next grant rather than how am I going to get this into a market application. I picked up on the technology, seeing it had potential for use at a higher temperature as a torrefaction technology. This led to an initial project which was demonstrated in Germany and then Spain. This was picked up by people from Namibia who explained their problems to me. This led to the superheat steam torrefaction demonstration in Namibia. We're now crossing the Valley of Death. So if we could go to the next slide, please. Next slide. Where we can talk about some of the issues that are facing, because I think it's important. What's the issues that we're looking at? High levels, back a bit, got very high levels of social income inequality in Southern Africa. The Gini coefficient, a measure of income inequality, is the worst in the world in South Africa and Namibia, possibly a legacy of apartheid. You've also got a massive amount of land that's been lost to bush encroachment and also alien invasives. You also have a high dependency on coal. Displacing coal is going to be an issue because it costs to move from coal to biomass. You lose efficiency. Whereas if you can turn a problem into an opportunity without sounding too generic, trying to take that woody biomass, give some value from it so that it then can become a clean cooking fuel, primarily for industry, but also for domestic use. But next slide, please. But it needs to have economic parity with coal, because no matter what people's good intentions are, if it costs more, they will not change to it. So going on to the next slide, we can see an image of bush encroach. Right. We're now talking about the torrefaction process. I'm not an engineer, but in its essence, superheated steam. Right, going back to bush encroachment, here's an image of bush encroachment, devastates the land, stops herbaceous plant growth, and it's wild, both livestock and wildlife can't survive in that sort of landscape. It really degrades the land. And if you can imagine the area in Namibia alone, 45 million hectares, that's larger than the area of France and Germany combined. Superheated steam has got great thermophysical properties, quite absolutely excellent for our application as a torrefaction media. Unlike traditional torrefaction, it's an inert atmosphere, therefore outputs both liquid and solid can be clean and do not give off products. So there is potential in the condensate that's recovered. So next slide, please. So that material recovered from this can be used for valorities. Right, next slide. So some simple diagrammatic, seems to have got a bit corrupted here, is that woody biomass is fed into a chamber which has a superheated steam atmosphere. The superheated steam is created from the moisture within the biomass, other than as initial purging. Temperature between 220 and 290 degrees C. It produces a condensate which contains biochemicals, which has commercial opportunity, and a torrefied biomass, which can be used as a direct coal replacement without any modifications to plant. So if you are a traditional industry user and you want to go from coal to biomass, you lose efficiency and you have to pay capital in upgrades. So there's two opportunities here. It's a saving for users in they don't have to spend money on capital and that plant does not lose in efficiency. Next slide, please. So if we do quickly, next slide, please. This, we applied for funding from a Green New Deal call, last call in Horizon 2020. It was a highly competitive. EU funding is becoming more and more competitive. When I first became involved in EU funding 30 years ago, it was relatively easy. The quality and demands now are very high. This is probably the best bid that I ever written, probably not sure if I'll write any more. The competition was fierce. 142 applications and only 4 projects were funded. It was a sister program to the LEAP RE program. I scored 15 out of 15. We had a 10 million euro project started in September 21, finished August 24. We're still finishing off the paperwork now on reporting. Thank you for the applause. My ego needs a boost. We covered multiple workflows. This just summarizes some of them. We were looking at technology implementation, design, build, demonstrate. Yes, there are issues that we need to fix going forward. We demonstrated with industrial users. We demonstrated with domestic users. We did quite a lot of market research. Dave Lello, who spoke earlier, was heavily involved in that program of work in South Africa, but also in Namibia and Botswana. We confirmed positive life cycle impact. And now we're very much moving on to the next step. So the next slide, please, where we go through what we have all heard about the value of. So here's pictures of the site in Cheetah Conservation Fund, which is north central Namibia, near Otjiwarongo. They have 60 hectares, is it, of land degraded by bush encroachment. There's a sample before and after. We still need to optimize the process a bit more. So if we go to the next slide, we're looking at how the next stage is to get that plant upgraded so that it can run standalone. We've proved technical viability, but we need that plant to be able to run as a cost center. To do that, we've identified what needs doing and the money we need. We're currently looking for that. We have a commercial call-off for the outputs of that plant running at 500 kilos an hour continuously. And if we get that, we'll both achieve that plant running to ensure the land there is cleaned up, but will also enable multiple 5-ton-an-hour plants all across southern Africa. So what we need to do is create secure rural employment, displacing coal cost effectively and restoring land sustainably. Thank you. I think that's the last slide. Next slide, please, where I just put acknowledgements down. Oh, don't forget, with all this, tying in economics and environmental and social responsibility, they go hand in hand. You cannot, despite what the 47th President of the United States thinks, you cannot have a sustainable future, an economic sustainable now without a sustainable future. Those are the benefits built into our business plan as we scale up and go forward, targeting those 4 SDGs. Next slide, please. And that's myself and my colleague, one of our colleagues. It was a 15-partner project, but taking it forward, my colleague in Namibia and myself as a joint venture to take it forward, very much driven by a commercial implementation to make it happen. Thank you very much.
Thank you very much, Hugh, for that presentation and also the insights, as well as the work that you're doing, especially in Namibia. We know that needed to be somewhere, and we hope that it's okay. We hope that it's okay for us to share some of your slides and perhaps your contact information to some of the participants who may be more interested in hearing about the work that you are doing. So thank you very much.
I'd be
yes,
delighted.
yes,
I'd be delighted to. I think there was a later version of the slides, so if you share the later version of the slides, if you've got them, those were the earlier ones, and also correct the date. I'm here for about 10 minutes. If you have questions, I'd be delighted to. I'll stay around for another 10 minutes.
Okay, great. So the floor is open. Hugh has been our last speaker for the day, and we'd like to take some questions. Please feel free to raise your hand and ask questions to any of our experts today. And we'll take also questions that are coming in through the chat. Any questions? Okay, from the chat, I saw a question. Somebody was asking, is there a benefit to doing biomass gasification rather than using it as a solid fuel? So I don't know who of our experts can try that question, respond to that question.
I can answer that. But gasification is used as a technology for many processes. It's used for biodiesel. It's used for sustainable aviation fuel. So there's a Fischer-Tropsch process, which is a well-defined gasification process. So gasification can only be used for heat. The gases can be turned into energy, electricity with a generator, but there are many examples of different gasification processes where chemicals are extracted from the biomass.
Thank you very much, Dave, for that. I think it was Mali Maita that asked that question. I hope that has been answered. But any of our experts can also feel free to chip in if they have to. I did see another question. It was sent to David Vera, and I saw he did answer it, but I could ask it again just for the benefit of those who may have missed it. This person was asking, is it possible to organize a visit of the pilot biomass conversion demonstrators for learning and networking activities in 2025 to 2026 for members of other projects working also in biomass and bioenergy? And can you please tell us again in which countries are the demonstration sites? This was David Vera, but I know there's some people who may have missed this question.
Yeah,
yes.
It's Matthew Brull. No, yes, it is. The two demonstrator plants are located. I start for the last question. The countries is in Morocco. One of the demo plants is in Morocco, in the region of between Marrakech and Essaouira, in the middle of the country. And the other demonstrator plant is located in Ghana, in the north of Ghana, in a rural area. The name is, the region of Saula, and the city, the village is Tuna. And yes, the objective of the demonstrator plan is to show to the academia, to the stakeholders, and to visit this and to see the operation, to see the plan under operation. And it is possible to manage a visiting and to keep in contact with the NGO that we are working on the site and the workers that they are on the site, and to create networking on the site. It is my email is in the presentation and also in the chat.
Okay, thank you very much, David, for that. I saw a hand up, somebody from GR Consulting, but then they've subsequently put it down. So are you able to unmute and speak, or was it a mistake?
No,
okay.
No, thank you. Thank you to all the presenters for a healthy and robust presentation. My question is to any of the speakers as regards to the blending of or using bioenergy fuels for blending for purposes of decarbonization of the aviation sector. I'm just wondering if there are any projects, and particularly around any policies and regulations that have been developed, maybe which country is the most advanced. And I ask this in relation to, like, now the EU already introducing as mandatory in their airports the use of sustainable aviation fuel. So from any of the presenters, could they be aware of any country that's already doing that in Africa?
Thank you very much for that question. Any of our presenters able to take that up? Any of the Davids or Hugh?
I'm not aware of any activity. I would say in terms of stakeholders, it's from our experience in Steam by Africa. I think Dave Lello was very much involved in this. We made sure that we did engage with local stakeholders and policymakers. And if you're going to do anything, if you do not engage with those participants, you are not going to move forward. You need to. So even in the small population we dealt with, just 3 countries, South Africa, Namibia and Botswana, even though they're right next to each other, there was a very clear difference in direction from a governmental level. And one of the actions we did do, we had a group of senior people coming over from Botswana to Namibia to exchange best practice and learn on best policy. That's would be what I would add to the conversation. Does that help at all?
Okay, yeah, it does. It does.
Okay.
Thank you very much. Yeah.
Thank you very much, Hugh, for that, and also for you've written you're marked as GR Consulting, but I'd say thank you for that question. I think someone else had asked something similar, but this was about he was requesting that the speakers discuss sustainable aviation fuels, especially how Africa can move from being a net exporter of feedstocks to a net producer of sustainable aviation fuels. So I don't know if any of you can take a jab at that. Is it possible for Africa? Yes.
I can do that.
Yes, Hugh.
There is a company in South Africa called Sasol. Sasol have been leaders in coal to petrol technology for many years through the Fischer-Tropsch process. And I do know that they're involved with basic research on bioenergy through different, and one of those is biodiesel and aviation fuel. They did make an announcement at the Mining Week, the Africa Mining Week last month, or earlier this month, to say that they had signed a memorandum of agreement with Anglo American, which is a large mining company, to look at these kind of projects. So if you were to look up Sasol and Biofuels, you will be able to see the number of partnerships they've done, but they are the biggest company in Africa producing fuels from coal, and they have a stated strategy that they're going to move to biostocks in the near future. So if you look them up, you'll be able to see what is being done in Africa. But I don't know of other projects outside of South Africa that are focused on biostocks.
I would add to Dave for what I've shared with you before. One of our other partners who advised that a lot of the all the Fischer-Tropsch processes in Europe that were using biofeedstocks experienced tar problems, and so there is a big technical challenge to overcome, is to remove the tar. Now, not promoting Steam by Africa in our process, but a feature of that is that we do remove the tar, so there is a potential opportunity for our technology and something that we have looked at on a long term as a feedstock for Fischer-Tropsch.
Yeah, I think just to add for anybody, for general, there are 3 pathways from biofuels or from feedstocks to biofuels. The first is heat treatment or gasification or any torrefaction, those kind of products. The second is to produce an alcohol, to ferment it, and then to use those base alcohols to convert them into biofuels and petrols and paraffins and aviation fuel. And the third pathway is to use anaerobic digestion to create methane and hydrogen, and then to change them into biofuels. So what I'm basically saying to you is that any aviation fuel has to go through 2 stages. It first has to go through from a basic fuel stock to an intermediate fuel stock. And once it goes from an intermediate fuel stock, it can then be converted into a final feedstock. And most of the research that's being done at the moment is the first process, the process of converting it from a raw feedstock into an intermediate feedstock. Because from an intermediate to feedstock to a final feedstock, those processes are well defined from the oil and gas industry over many years. But the first step is not well defined, and there are many research papers on this. And I think those are the areas that Sasol is working on. I'm not aware of any other research in Africa at the moment.
All right, Dave and Hugh, thank you so much for responding to that. We have a few questions, mostly asking about sharing contacts and research studies on biofuels, including West Energy. Please look through the chat. We shared a link for LIPRI, which has many of the projects that are ongoing, and we'll also share the slides of the presenters who will share their information as well as their web addresses, so that you can be able to look at the different projects that they're doing. I hope that answers your question. I do see another question. This is Gordiana Filippo, who's asking, do you have any clues on the importance of using clean cooking using solar directly rather than the use of biomass? Did anyone take that up? The importance of using clean cooking using solar directly rather than using biomass.
I think within the use of solar, you need to have your storage capability, but also I think with any, there's more people, I think Dave, I'm referring to Dave a lot here, Dave Lello, is the transition from a traditional cooking means to a new cooking means, and conservatism of people and the need to spend money. I think Dave Lello and his clean cooking stoves are a good example where you combine the ability of traditional cooking techniques, because it's going to a completely new cooking technique, can create lots of social barriers and fear.
Okay. All right. Thank you, Hugh. The next question is to David Jesse, who talked about legal frameworks, and it would be what recommendations would you give to policymakers to create a more conducive regulatory environment for biomass and biofuels, especially in terms of incentivizing investment and innovation within the sector?
Yeah, I think my direct answer to that is that the policy formulators, especially our government, should open the space for conversation, and especially bring on board the private sector and even the CSOs to really engage in the development process and formulation of those particular policies. What you've seen as a success in Kenya, and especially when you're developing the national bioenergy strategy, is that actually the initiative came from the private sector itself. And so that gave it a very big boost in terms of the coverage and scope of that particular strategy, to the extent that now we have very smart provisions for private sector engagement. So in Africa, I think it's about opening up the conversation and letting private sector and every other interested stakeholder, especially even the CSOs, and when it comes to mobilizing communities, because our policy frameworks must have in focus communities engagement. We must look at our needs. That's why, for example, for me, country differ from country, and for example, in Kenya, what's our priority? Is it sustainable aviation fuels? I don't think so. I think our priority is to increase clean cooking technologies in the country. So when you come to South Africa or even the North African countries, you find out that there's a lot of development in the area of bioenergy technology. So yes, you can involve in other things. But my basic answer is that our governments must open up for more inclusion of private sector and CSOs engagement in policy formulation. But if that is not happening, it is up to the CSOs, it's up to the private sector to press in and ensure that they're included in those conversations. Thank you.
Right. Thank you very much, David Jesse, for that. I think the next question would be to David Vera, and it's based on also the work that you have been doing. What role do you think local communities play in implementing or integrating waste management systems, and how do you think their involvement can be encouraged to ensure success of the projects, especially the biomass and biofuel projects?
Sorry, Jovia, I didn't catch you because the sound of the microphone is not very good. Can you repeat?
Okay, can you hear me better now?
Yes.
Can everybody else hear me?
Yeah, fine.
Yes, yes.
Okay, so David, I'm asking, what role do local communities play in the implementation of integrated waste management systems, and how can their involvement be encouraged to ensure success of renewable energy projects based on the work that you're doing?
With the local community, we are working on the site. For example, in Ghana, we are making some training courses on the site to make some operators. For example, the objective of our plant is to make operation because maintenance and operation of the plants is the life of the plants. Okay, if you don't introduce good biomass according to the manufacturer requirements, if you don't make the maintenance tasks according to the operation manual, the system is going to fail and is going to not operate. So we join the community on the site with some training courses on the site. So we develop training courses, we develop an operator, a leader of the courses, and he showed to the community the operation and the technology transfer to the local community. Also for farmers, because it is important that in our cases, for example, in Ghana, the biomass, we use peanut shells and cashew nuts. So currently there is no valorization in these kinds of wells. Directly they are burned up in the fields directly. So we try to make workshops with them to explain that the biomass can be used to produce electricity, to produce drinking water in the future with electricity, and try to join us to this kind of workshops to the community.
Okay, thank you very much, David, for that. I just have questions for Dave, Matthew, and Hugh. I don't know if Hugh's still on. I know he's supposed to leave, but for Dave, what challenges have you encountered in development and deployment of the SHG solution, especially regarding user adoption and local market conditions?
Yeah, the challenges always are cost. We didn't discuss it David didn't discuss it earlier, and I didn't discuss it, but the people who have electricity in urban areas and people who have affordability will use LPG and gas. I mean LPG and electricity. The lower portion of the population and where energy poverty is most prevalent is people that use charcoal and or wood. So, and those are many in peri-urban areas, in lower income areas of cities, and cost is the major thing. So I think there's a natural process that as wood becomes more scarce in Africa, the price of charcoal, the inflation of charcoal is sometimes double digit, sometimes over 20% per year. So as wood becomes scarcer and scarcer, I think that some of these alternative energy solutions are probably going to become, will force people to move. But up until now, tradition in Africa is very strong. Somebody that uses something for many generations to be able to offer them a solution is one thing, but to get them to move from one technology to another, it requires a lot of capital and money to be able to get the message out there. So it's the technology exists. You know, many of the presentations this morning have shown wonderful technologies, but being able to get that across to the population and for them to adopt it, adoption, and the cost of getting people adopting it is the challenge. That's the biggest challenge.
Yeah.
The technologies exist.
Thank you.
I have put on the group, there is a website called www.propellets.africa on the chat. That's a website, and there is a working group within the World Bioenergy Association on advanced solid fuels for Africa. We meet once a month and share knowledge and experiences. So if anybody wants to join those sessions, they're welcome to email me at david@gazi.energy, and I will invite you to the next sessions.
All right. Thank you very much, Dave, for that. I think the need for, buy-in, especially I think the work for the CSOs is cut out, and also a bit more funding. We have posted a Slido link. Please do let us know what you think, because this feedback is very important for us going forward into other webinars. And as you answer, I'll just continue asking questions to our panelists today. So please do answer, fill out the questions that are coming up on Slido. They'll be very important for us to give you better experiences going forward. So the next question is to Matthew. And because of because of the work that you're doing, I wanted to ask, what challenges do you think African countries are facing in transitioning to a circular economy model that incorporates biomass, and how can these challenges be addressed through especially policy and innovation? I've had Dave mention it's difficult to convince people to get away from what they've been doing. So what challenges have you experienced working in African countries?
Yes, okay. So I will answer two questions. So I answer briefly about solar energy for cooking. You need a very big mirror to build a very big mirror to concentrate enough solar energy to reach a high temperature for cooking. You can find on the internet, there are a lot of experiments in India regarding solar cooking, and they have a very, very big mirror. It's very expensive to build it. And then when weather is bad, it will not work. When the weather is cloudy or rainy, the cooking system will not work because you need to reach this high temperature. So better you use solar energy, either as PV solar for electricity or as thermal solar for hot water, or as to concentrate it for solar drying. Solar drying also works very good. So I replied this first question to complement the previous reply. The challenges, I say, is to create a very strong public sector. I guess like it's very important, like the best contact that we have is to public university and public research institutes in Africa. And the second challenge would be to bring together these public research institutes and universities together with associations and the private sector. The way that we communicate is very different. Like in Europe, we communicate a lot with by writing and by contracts. And in Africa, people communicate like right now with speaking, like a very big meeting, and everybody can be speaking, and with direct communication via WhatsApp. So they have different ways of communicating. So when you organize a meeting, a long time in advance to make a doodle and make sure everybody can go to this meeting to try to bring the people together. So, and make sure that there is peace in Africa, good situation, social equality, and so on. Then you create a good framework to experiment local solutions in Africa.
Thank you very much, Matthew, for that. Dave, I see your hand is raised. Did you want to say something, or?
All done,
okay.
all done.
Okay, great. So this is bringing us to the end of our session. Please don't log off yet because we need to hear some closing remarks and perhaps some information from our colleagues from AESG. Thank you so much for being an engaging audience. Please continue to respond to the questions on the poll, on the Slido poll. It's still very active. A special thank you to our speakers today for all the insights and for all the work that you're doing across Africa. And we hope that we have another opportunity to have more of this, probably with more time, because we know we were quite hard on you with time. And I'd like to invite our colleagues from ASG, perhaps Grace, to give closing remarks and the way forward. Thank you.
Thank you all.
Thank you very much.
Thank you all for joining the session. Thank you for the engaging discussions. Thank you for the speakers and the experts. I've never seen a chat this alive in our webinars. So we're grateful for all the participants who are able to join. Quite a lively discussion. And I think the thing that was quite clear is a collaboration in the triple helix model. That is a collaboration between government with regards to policy formulation and a good framework to support biomass and biofuels usage. Then academia needs to come up with the solutions that can be used by society with regards to the various factors, the PM index, the greenhouse gas emissions, like showing exactly how much everything and quantifying the value of the solution in comparison to the traditional models that have been used, and then private investors coming in and assisting to bring those solutions into market to scale them up. So from the different presenters, we were able to get that information. We saw the practical implementation of the projects. Reflect was able to show what they're doing in Ghana with cashews and peanuts. Morocco with the olive oil bioproducts, as well as what are the barriers that they're encountering with regards to lack of net metering tariffs that can incentivize people to use some of the energy and give back the energy into the grid for revenues. David Ledlow, I think your presentation was quite simple. It was short and sweet and very useful with regards to how much was able to point out that how much Africa is trailing with regards to research, as well as lack of producing effective cook stoves that can be scaled to every community or every rural community that is very much in need for them to stop using the wood and charcoal that is traditionally being used. And Hugh, your project in Namibia is also very impactful. I hope it proceeds to the very end. We'll keep looking at it and monitoring its progress, employment, and how to displace coal use and also restoring land use. So all this has been quite informative, and we're grateful to the listeners and the panelists and the moderators and your patience in being with us and coming on board. We shall be communicating and sharing the links, the various links that have been shared in the chat, as well as the presentations as were given by our expert panel. And we shall communicate for any future developments with regards to a follow-up webinar on this, because I feel it's just a tip of the iceberg and we can do more and reach more people. So let's keep in touch. You'll see us on mail. We'll reach out and share also the recording. And any other questions can be responded to. You can share on mail. Our mail is as shared in response to your attendance, and we'll keep a record of it. And hopefully, if there are any things that come up, feel free to to participate in any other webinars we create, not only on biomass and biofuels. So thank you for the support, and we can say goodbye and good afternoon to all. Is there any other information I may have forgotten? Sheila, you're part of my technical support.
No, not really. Thank you. Like you said, we will share the presentations and the information that we have, the links, and that we will share after. And also we can do a survey after. We will appreciate if you fill it for us so that we can know how best to have improve our webinars in the future. I think that's all from my end, and thank you so much for joining us.
All right. Thank you very much. Special thank you again to our expert presenters, and we look forward to doing this again, and we'll share more information via email. Please feel free to leave at your pleasure.
Thank you very much.
Thanks a lot. Bye-bye. Have fun.
Thank
Thank you.
you.
Bye.
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 Thank you.
Thank you.
Bye-bye.
Welcome.
Bye-bye.
Great.
And please, let's leave the meeting now so that we can save the recording. Thank you all. Thank you.
Yeah. Thank you, I know.